Next topic is logarithmic differentiation. So logarithmic differentiation is used when we have an x term or a y term raised to an x term or a y term. We have logarithmic differentiation when there is x term or a y term raised to x term or a y term, or we also call it as that basic understanding is it is a function raised to function. So whenever we have x term raised to x term or y term and y term raised to x term or y term, we have a function raised to function. In other words, we use logarithmic differentiation. Now remember this, certain pointers is, I know that y ka derivative is dy by dx, which is also denoted by y dash. In the same way, if someone asks me ki what is the derivative of log y, it will become 1 upon y into derivative of y, and I know that derivative of y is dy by dx. Anybody has any doubts? Now, I had given a remark that the first lecture में that x raised to x का derivative, see, that d by dx of x raised to x is equal to x raised to x log 1 plus log x. Okay. Now how does this come? I'll show it to you. Now we start with, the question is y is equal to x raised to x. Since it is function raised to function, what we do is we take log on both sides. So log y is equal to log of x raised to x. Now the power of the variable becomes the coefficient of log. The power of the variable becomes the coefficient of log. So log y will become x log x. I'll differentiate with respect to x. Log y will become 1 upon y dy by dx is equal to x into 1 by x plus log x into 1, which is equal to 1 plus log x, and this is 1 upon y dy by dx. Therefore, dy by dx will become y into 1 plus log x, and I know that y ka value is x raised to x. So this will become x raised to x 1 plus log x. So this is how we understand, since it's been used for a very long time, it's used a lot. So we know that derivative of x raised to x is nothing but x raised to x bracket 1 plus log x. What is the actual explanation? This entire sum is an explanation. So basically this is a sum, and this is how we proceed with the sum. Now for example, if I have a question, if I take a question, logarithmic differentiation, imagine the question is this. Say for example, y is equal to x plus 1 upon x plus 2 the whole square and x plus 3 the whole raised to 4. Now you can solve it normally. You can expand the numerator, you can expand the denominator, you can do u upon v, you will get the answer. But it will become very lengthy because you will have to do u upon v and then internally you will have to do u into v. So it becomes a very lengthy sum. So we also remember one thing, that to do complex or long calculation, we use logarithmic differentiation. How? See this. If I take log on both sides, this will become log y is equal to log of x plus 1 upon x plus 2 the whole square, x plus 3 raised to 4. Therefore, log y will become log of x plus 1 minus log of x plus 2 the whole square x plus 3 raised to 4. Now log a plus log b will become log ab. ठीक है. So log a plus log b becomes log ab. So what I do is this will become log y is equal to log of x plus 1 minus log of x plus 2 the whole square plus log of x plus 3 the whole raised to 4. Now log y will become log of x plus 1 minus 2 log of x plus 2 minus 4 log of x plus 3. Therefore, if I differentiate, this will become 1 upon y dy by dx, and this will become 1 upon x plus 1. Now log ka derivative is 1 upon x plus 1. Can you tell me what will be x plus 1 ka derivative? 1, because x ka derivative is 1 and 1 ka derivative is 0. Minus 2 upon x plus 2 minus 4 upon x plus 3, and therefore my final answer will become, this y will go that side, so dy by dx is equal to, y has gone that side. Now guys, since y has gone that side, what is the value of y? X plus 1 upon x plus 2 the whole square x plus 3 raised to 4 into 1 upon x plus 1 minus 2 upon x plus 2 minus 4 upon x plus 3. Okay? So what we have understood is, this is how you're supposed to proceed when this to multiply. There is no root here. So normal calculations, how we're supposed to proceed is, we are supposed to solve, we're supposed to make sure that this is the process whenever you have a complex or a long calculation where there's addition, multiplication, subtraction, everything. All you're supposed to do is, you're just supposed to take log on both sides and you're supposed to solve the sum. Anybody has any doubts here? Now listen. If I get a sum like this, y is equal to, okay, x raised to x plus x raised to a plus a raised to x plus a raised to a. Now we already know the explanation for x raised to x. So when I solve this, see what I'm going to do. I'll take dy by dx is nothing but d by dx of x raised to x plus d by dx of x raised to a plus d by dx of a raised to x plus d by dx of a raised to a. Now this you'll have to solve this separately. How? You'll have to write let u is equal to x raised to x. You'll have to write the entire thing. So in place of y, it will become u, 1 by u du by dx. You ultimately will get the same answer. So I can say that du by dx is nothing but x raised to x bracket 1 plus log x. And my final answer would be dy by dx is equal to x raised to x bracket 1 plus log x plus x raised to a is nothing but x raised to n, a into x raised to a minus 1 plus a raised to x log a, and derivative of a raised to a, since it's a constant, my answer will be 0. Anybody has any doubts here? Now, these were all without trigonometry. What will happen if I have terms of trigonometry? Example. You can't derive it directly, no? You'll have to take log on both sides. So you ले लिया. You'll have to solve it separately. So log u is equal to log x raised to x, log u is equal to x log x, 1 upon u du by dx. So everywhere same, it will only, in place of y, it will be u. If it comes in the exam. If it comes for MCQs, you don't have to show anything. You know this discussed it, and these are direct formula. Okay. Now imagine my question is this: sin x raised to tan x. Okay. My question is sin x raised to tan x. I'll take a question: sin x raised to tan x. Sin x raised to tan x. I know this is logarithmic differentiation because it is a trigonometric function raised to a trigonometric function. When I take log on both sides, this will become log y is equal to tan x into log sin x. And when I derivate this, if I derivate this, this will become 1 upon y dy by dx is equal to tan x. Guys, what is the derivative of log sin x? Log sin x का derivative become 1 upon sin x. What is the derivative of sin x? Cos x plus log sin x into derivative of tan x. Can you tell me what is the derivative of tan x? It is sec square x. Now when I solve it further, it will become like this: 1 upon y dy by dx is equal to tan x into cos x upon sin x plus log of sin x into sec square x, which will ultimately become 1 upon y dy by dx is equal to tan x into cot x plus log of sin x into sec square x. This gets cancelled. So therefore I will get 1 upon y dy by dx is equal to 1 plus sec square x into log sin x, and the final answer would be dy by dx is equal to y into 1 plus sec square x into log sin x, and y का value is nothing but sin x raised to tan x. So this will become sin x raised to tan x into 1 plus sec square x into log sin x. We are doing the same step again and again and again. Function raised to function, take log on both sides, the power becomes the coefficient. You have to do u into v, and once you do u into v, that is the final step.
I didn't understand how sin x was raised to tan x in the last step.
Why is sin x raised to tan x?
That's how you said.
We are doing the same step everywhere. Last step is always the substitution. When y went from this side to this side, my y ka value is, if you see, my y ka value here is x plus 1 upon x plus 2 the whole square x plus 3. Did you understand this? Every step of logarithmic differentiation is exactly the same thing. Same thing. We are not doing anything extra. We are not doing anything extraordinary also. Now, if I change the question a little bit, again, it will not matter a lot. The sums will only become lengthy. Now, imagine my question is, y is equal to Sine inverse x raised to x plus x raised to cos inverse x. ठीक है, sin inverse x raised to x plus x raised to cos inverse x. The problem is, unlike the previous sums, since in this sum there was only one x raised to x function, so I took it separately and solved it. Here there was only one function raised to function, so I could take log on both sides. The problem here is we have two sums. This is an individual sum, this is an individual sum. I can't take log because there is no formula for log a plus b. There is no formula for log a plus b. Log a plus b is not equal to log a plus log b. There is no formula such. So what we are going to do is, there is no formula. So what we are going to do is, we are going to solve it separately. How? Let y is equal to u plus v. Therefore, dy by dx is equal to du by dx plus dv by dx. I repeat, therefore dy by dx is equal to du by dx plus dv by dx, and this is my equation 1. Now I'll treat it normally. I'll write let u is equal to sine inverse x raised to x. Since u is equal to sine inverse x raised to x, when I take log on both sides, this will become log u is equal to log of sine inverse x the whole raised to x, which will become log u is equal to x log sine inverse x. Now I'll do u into v. So 1 upon u du by dx is equal to x into 1 upon sine inverse x into, what is the derivative of sine inverse x is 1 upon under root of 1 minus x square plus log of sine inverse x into 1 because this is product rule, u derivative of v plus v derivative of u. Therefore du by dx will become, u will go on that side, so this will become u into 1 upon root of 1 minus x square into sine inverse x plus log of sines. The last step would be क्या हुआ? X. क्या हुआ? Log of sine inverse x, huh? Now, and the last step would be du by dx will become, u is nothing but sine inverse x raised to x. So sine inverse x raised to x into x upon under root of 1 minus x square sine inverse x plus log of sine inverse x. Guys, this is my equation 2. These are individual sums. We are going to solve it together. So I'm just showing you how different it is. So I've solved the first part. U हो गया. Let v is equal to x raised to cos inverse x. Now again the same process will start. Log v is equal to cos inverse x into log x 1 upon v dv by dx is equal to cos inverse x into 1 upon x plus log x into 1 upon minus 1 upon root of 1 minus x square. Because derivative of cos inverse x is minus 1 upon root of 1 minus x square. So 1 upon v dv by dx is equal to cos inverse x upon x minus log x upon under root of 1 minus x square. Now I'll take v on that side, so dv by dx will become v into cos inverse x upon x minus log x upon root of 1 minus x square. And now I'll just substitute the value of v. If you see, this is your v, x cos inverse x. So x raised to cos inverse x into cos inverse x upon x minus log x upon under root of 1 minus x square. This is your equation 3. Now if I combine, if I substitute 2 and 3 in 1, if I substitute 2 and 3 in 1, if I substitute 2 and 3 in 1, I'll just write substituting 2 and 3 in equation 1. Therefore, dy by dx will become, this is your du by dx. So this will become sine inverse x, the whole raised to x, into x under root of 1 minus x square sine inverse x plus log of sine inverse x plus this is x raised to cos inverse x into cos inverse x upon x minus log x upon under root of 1 minus x square. So we have done the first differentiation individually taking log, the second differentiation individually taken log, and the last step what I've done is I've substituted equation 2 and equation 3 in equation 1. Did you guys understand this? We're going to do the same step again and again and again and again. So you don't have to do anything extraordinary. What you're supposed to do is just solve the sums normally. If there are 2 different terms or 3 terms or 4 terms or 5 terms, all you have to do is just solve all the terms individually, because there is no formula for log a plus b. If in the first step I take log on both sides, it will become log y is equal to log of this entire thing. It will become more complicated for you. So it's always advisable that you start with y is equal to u plus v. The derivative of y is dy by dx, the derivative of u is du by dx, and the derivative of v is dv by dx. Has everybody understood this? Anybody has any doubts here? So now, in the same way, y is equal to e raised to log of log 3x into y is equal to e raised to log of log x into log 3x. Now remember, the base is not given to you. The base is not given to you. Since the base is not given to you, I have the luxury to take the base either as e or either as 10. Now in your school level preparation, when you are doing these kind of sums, they never write ln. Ln is basically log x to the base e. It's always given to you. It's understood कि ln ये होता है. Now in your respective school curriculum, in your school papers also, school level papers, board papers, we never mention ln. They always write log. Now since they have not given any base, we have the luxury of taking the base as e or 10. Because log is 10, 1, and log 10 is also considered as 1. So I can write like this: log to the base e log x into log 3x. Now remember this remark: e raised to log x to the base c is x. E raised to log x to the base c is x. Now why does this happen? When exponential goes from one side to another, this entire term, it will go there, it will become like this. E raised to x is equal to e raised to x आ जाएगा. X to basically x is equal to x. Now I have got the values x. So if you take log on both sides and if you solve, you'll exactly get the same sum. So we understand that e raised to log x to the base c is nothing but x only. So my question will become y is equal to log x into log 3x. Even though exponential function I could have done u into v, but I have simplified this sum looking like this. And now what I'm going to do is, when I derivate this, I will directly write u into v. So u into 1 upon 3x into derivative of 3x, that is 3, plus log 3x into 1 by x. This gets cancelled, this gets cancelled. And my final answer is dy by dx is equal to log x upon x plus log 3x upon x. Since my denominator is same, what will be log x plus log 3x? What will be log a plus log b? So log 3x square upon x. Have you guys understood this?
Yes.
We have done the entire sum without logarithmic differentiation. Just because we know the first step, that e raised to log x to the base c is always going to be x. Anybody has any doubts here? Yeah, only apply to any base. The base and the actual base should be same. If here you have 7 and if you have 7, they will eliminate each other. Okay. Now the question is this: y is equal to tan x find dy by dx at x is equal to pi by 4. Okay. Now it might look very complicated. It is not. It might look very complicated. It is not. It is not complicated. Now what you're supposed to do is, if I solve this, this will become y is equal to tan x. Now it's become easy. So when you have these kind of sum, we have the luxury of multiplying it. So it becomes tan x raised to tan square x. Now it becomes an ordinary sum like this. Single term. It's basically a single term like this. Sin x raised to tan x. So what we do is, when I solve it now, I'll take log on both sides. So this will become log y is equal to tan square x into log of tan x. Log y is equal to tan square x into log of tan x. Now when I do differentiation here, it will become 1 by y dy by dx is equal to first term into derivative of second term. Now see this. Log of tan x is 1 upon tan x and derivative of tan x is x square x plus ठीक है, u derivative of v plus log of tan x into tan square x का डेरिवेटिव. सबसे पहले बेसिकली दिस इज tan x द होल स्क्वायर, मतलब दिस विल बिकम 2 tan x into this is like x raised to n. What is the derivative of x raised to n? N x raised to n minus 1 into derivative of x. into derivative of x. Here, what is x? Tan. What is n? 2. So it will become 2 tan x into derivative of what is x here? Tan x. Did you guys understand this? So what is the derivative of tan x, guys? Very good. Into sec square x. Have you guys understood this? So this is on the same lines of x raised to n. So यहाँ पे you can write a remark. See, this is basically nothing but x raised to n. Okay, this is x raised to n. Now ये हो गया cancel. This gets cancelled, this gets cancelled. Okay, so I'm left with 1 upon y dy by dx is equal to tan x into sec square x. Okay, this is the first term. Plus log of tan x into 2 tan x into sec square x. Now they have said that x is equal to pi by 4. Okay, so I'll just take y on the right hand side. So if I take y on the right hand side, this will become dy by dx is equal to y into tan x into sec square x plus log tan x into 2 tan x into sec square x. Okay, this is what we have done. Now we'll substitute the value. Now we'll substitute the value of y. So dy by dx is equal to tan x raised to tan square x into tan x into sec square x plus log of tan x into 2 tan x into sec square x. And now I'll substitute x ka value as pi by 4 and I'll write at x is equal to pi by 4. At x is equal to pi by 4, my dy by dx, this will become tan pi by 4. I know that tan pi by 4 is 1. So it will become 1 raised to 1 square into 1. Sec pi by 4 is root 2. So root 2 square plus, what is tan x? Tan pi by 4. What is tan pi by 4? 1. What is log 1? 0. Log 1 is 0. And since this is 0, the entire term becomes 0. Therefore, dy by dx is 2. This is your answer. Has everybody understood this?
Yes.
Dy by dx has become 2 because term after log has become 0 because log 1 is 0. Okay. Last sum of logarithm and differentiation. Y is equal to sin raised to mx upon sin raised to nx upon m plus n into sin raised to nx sin raised to px upon n plus p into sin raised to px upon sin raised to mx upon p plus n. So now I need to find dy by dx. Okay. Now m and n are constants, I know, but there are too many terms. You can use log and you can solve, you'll get it. But this is a normal example of algebraic function. Now when I simplify algebraic function, what I'm supposed to do is, I'll write y is equal to, सबसे पहले I'll write it like this. And this will become sin x raised to p upon sin x raised to m upon p plus m. As the term goes in the numerator, it will become sin x raised to m minus n, the whole raised to m plus n, sin x raised to n minus p, the whole raised to n plus p, and sin x raised to p minus n into p plus n, which will become y is equal to sin x raised to m square minus n square into sin x raised to n square minus p square into sin x raised to p square minus n square, which will become sin x raised to m square minus n square plus n square minus p square plus p square minus y is equal to sin x raised to 0. Therefore, y is equal to 1. Therefore, dy by dx is equal to 0. So these are all the sums that are required for you to understand logarithmic differentiation. Next topic is implicit function. Now till now all the sums that we have done, guys. Till now all the sums that we have done. We always started with y is equal to y is equal to. This is how we usually started with all the sums. Now for the implicit function, the equation will be given to you with a combination of x and y both. And what does this mean? Now see this. Imagine my question is this. Root x plus root y is equal to root a. We are not writing the question as y is equal to. They have just given me an equation where x and y are written together. So what I'm supposed to do is I'll directly differentiate this. Therefore, root x will become 1 upon 2 root x. As you know that root y will become 1 upon 2 root y into dy by dx. And since root a is a constant, it will become 0. And ultimately I have to find dy by dx, so I'll write 1 upon 2 root y dy by dx is equal to minus 1 upon 2 root x. This 2 and this 2 gets eliminated. Therefore, I know that dy by dx is minus under root of y upon under root of x. We have not done anything extraordinary. What we are doing is we are just finding the values. In other words, we are just finding dy by dx. We are not finding anything else. We are just finding dy by dx. Now, if we take one more question, okay, if we take one more question in the same way, say for example, the question is x raised to y is equal to y raised to x. We just did logarithmic differentiation. So, x raised to y is equal to y raised to x. Now, what I'm going to do is I'm going to take log on both sides. So, taking log on both sides. Okay. So, this will become log x raised to y is equal to log y raised to x. Therefore, y log x is equal to x log y. Now, see, it's very important for you kid in implicit function. The major step is you have to take all the dy by dx terms on the left hand side and non dy by dx terms on the right hand side. So what you're supposed to do is take all the dy by dx terms on the left hand side and non dy by dx term on the right hand side. So see what will this become. If I differentiate this, so y into 1 by x, y into 1 by x plus log x into dy by dx. Now listen, I'm just writing it one below the other so that it becomes easier for you to see it, is equal to, again, x into 1 by y dy by dx, u derivative of v plus log y into 1. So if you see this step, I have 1 dy by dx term on the left hand side and I have 1 dy by dx term on the right hand side. Now, as I told you guys, what you're supposed to do is you're supposed to take all the dy by dx term on the left hand side. You're supposed to take all the dy by dx term on the left hand side and non dy by dx terms on the right hand side. So what I will do is, if I have to solve this, this will become, सबसे पहले अरेंज कर लेंगे नहीं, so let's take, this is your dy by dx term, this is your dy by dx term, so this will become like this, log x into dy by dx minus x upon y dy by dx is equal to log y minus y upon x. So this term and this term are your non dy by dx terms. This term and this term are your dy by dx terms. So now what I am going to do is I am going to take dy by dx common. If I take dy by dx common, I am left with log x minus x by y is equal to log y minus y by x. Now when I take the LCM, this will become dy by dx y log x minus x upon y is equal to x log y minus y upon x. And now finally, when I cross multiply, I will get x into y log x minus x upon y into x log y minus y. So nothing different. All we have to do is we are taking all the dy by dx. Achha. Y bracket x log y minus y upon x bracket y log x minus x. So what we have done is we are taking all the dy by dx terms on the left hand side and non dy by dx terms on the right hand side. So again, since we just did logarithmic differentiation, there's nothing we are doing, it's function raised to function. This is a normal equation. What I have done is I have just taken the derivative. A is a constant, x and y are the functions of each other, y is a function of x. So dy by dx, I have got the answer in terms of x and y. Now, if I have this question, x square y square is equal to tan inverse of under root of x square plus y square plus cot inverse of under root of x square plus y square. A little bit of inverse. Can anyone tell me how will we proceed with this one? Tell me the first step. Derivate. Barabar? Because I have tan inverse x का derivative also and cot inverse x का derivative also. Now, sin inverse x plus cos inverse x is pi by 2. Tan inverse x plus cot inverse x is pi by 2. And cosec inverse x plus sec inverse x is pi by 2. So इसका आंसर डायरेक्टली क्या रहेगा? Pi by 2. So my question will become x square y square is equal to pi by 2. That's it. That's it. So if you derivate it, that will become too lengthy for you. But because in trigonometric functions, we know that tan inverse function angle, tan inverse value plus cot inverse the same value is going to give you pi by 2. It has to be same. And now if I differentiate this, is the first term into derivative of second term plus second term into derivative of first term is equal to 0. Therefore, 2x square y dy by dx is equal to minus 2xy square. Your 2 gets eliminated, your 1x gets eliminated, your 1y gets eliminated. Therefore, dy by dx is equal to minus y by x. So if you derivate this, this is definitely going to be more than 4 lines.
The answer will become the same.
Of course, because इसका डेरिवेटिव and इसका डेरिवेटिव बीच में माइनस आ जाएगा, it gets cancelled. But remember, you'll have to do tan inverse का derivative, then you'll have to root का derivative, then x square का derivative, then y square का derivative. So it will become too tedious. So that's why this is just become shorter if you remember the formula. If and only if you remember the formula. Now, since we know inverse formulas, since we know all the formulas, my next sum becomes like this. For example, y is equal to sec of x plus y upon x minus y is equal to a square. Okay. Show that, I'm telling you, show that I have to prove this. dy by dx equal to y by x. Now, these are some pattern sums. Now, what do you understand by pattern sums? Whenever you have something like this, sec ka angle is something of an equation. It can be a linear equation, it can be a quadratic equation. Now, some people are not y. Sorry, the question is written wrong. It's not y. It's basically this. This is the question. Sec inverse of this is equal to a square. I have to prove this. Now, step number 1. I will take sec on the right hand side and it will become sec inverse a square. Now I can clearly see that the right hand side is a constant. So why write such a big constant? I will replace this constant with a small constant. Constant here to write a small constant. Now a lot of people will say that let's do component to dividend here. You can do component to dividend here. You can do component to dividend here. Remember this. Basically, if you do component to dividend, that's okay, that's not a problem. If you do component, that's fine. If you solve it by normal algebra, that is also fine. You get the same answer. You do component to dividend, you get the same answer. You do by normal algebra, you get the same answer. Now see this. So if I do x plus y is equal to bx minus by, therefore y plus by is equal to bx minus x. Bx minus x. Therefore y bracket 1 plus b is equal to x bracket b minus 1. Therefore, y is equal to b minus 1 upon b plus 1 x, which is again, it's too big a constant. So I will write let b minus 1 upon b plus 1 is equal to c. Therefore, y is equal to cx. देखो ध्यान से. Okay. Y is equal to cx. And if I derivate it, what is the value of c?
Y by x.
I have put in the bracket. Still you miss it. What is the value of c? Y by x. Did you guys understand this?
Yes.
We have done one step of differentiation. One. In the entire sum, we have done only one step of differentiation. And that too, we have differentiated x. The whole sum is basically combination of entire algebra. We have not even done inverse. Just taken on the right hand side. That's it. So in any sum that comes like this, now it can be cosec inverse of x square, x cube, x raised to 10 plus y raised to 10 upon x raised to 10 minus y raised to 10 is equal to a square. The answer will be in on the same lines. Remember this. So if you come across this pattern sum, this is how you're supposed to proceed with this sum. Has everybody understood this? Anybody has any doubts here? So what we have done is I've taken sec on the right hand side. It's a bigger constant. I've taken it by smaller constant. Simplify it. Again, I got a bigger constant. I substitute the smaller constant. I derivated it and c ka value directly from the box. I've understood that c ka value is y by x. Anybody has any doubts here? Have you guys understood this? Yes. Now, we'll do this sum, one sum. Now, imagine the question is this. Log to the base 10 x cube minus y cube upon x cube plus y cube is equal to 2. I have to find dy by dx. Now I'm not going to give you what you're supposed to prove. So, सबसे पहले when log goes from one side to another, it becomes exponential. Again, you can do componendo dividendo. You can do componendo dividendo here. You can do componendo dividendo here. But since in the previous sum we have just solved it by normal algebra, what I'm going to do is equal to 100 x cube plus 100 y cube. 100 x cube plus 100 y cube. Next, what we are supposed to do is I'll take all the y terms on one side, x on one side. So this will become minus y cube minus 100 y cube is equal to 100 x cube minus x cube. This will become minus 101 y cube is equal to 99 x cube. And now when I differentiate this will become minus 101 into 3y square dy by dx is equal to 99 into 3x square. My 3 and my 3 gets cancelled. Therefore, dy by dx will become 90 minus 99x square upon 101 y square. Again, just derivated this, nothing else, one line, normal algebra. So again, you can go by component rule. This will become 100 plus 1 upon 100 minus 1. This will become, if you add this, it will become 3 2x cube, and this will become 2y cube. You'll get the same answer. You ultimately get number of steps also will be the same only. You get exactly the same step. So depends on you what is comfortable for you. You are going to proceed with those kind of questions. Okay. Next, y is equal to root of log x plus root of log x plus root of log x up till infinity. ठीक है, up till infinity कुछ नहीं करना. I'll square both sides, so this will become log x plus root of log x plus root of log x plus infinity. Now if you carefully see, this is nothing but y, because y is starting with root log x and it is ending at infinity, and this term is also starting from root log x and it is ending at infinity. So y square is equal to log x plus under root of this. So what you're supposed to do is, when I solve this sum after this, so this will become y square is equal to log x plus y. That's it. Y square is equal to log x plus y. Therefore 2y dy by dx is equal to 1 by x plus dy by dx. Therefore 2y dy by dx minus dy by dx is equal to 1 by x. And if I take dy by dx common, it will become 2y minus 1 is equal to 1 by x. Therefore dy by dx is equal to 1 upon x 2y minus 1. Not done anything extraordinary. I've just made a very complicated question that looks very complicated. I've made it into a basically quadratic, you can say. Y square आ गया, y आ गया, and log x, where we take log x as, if I talk about quadratic, log x will be nothing but c. Has everybody understood this? Now, a very special sum. E raised to x plus e raised to y is equal to e raised to x plus y. Okay, it's a very, very, very important sum. E raised to x plus e raised to y is equal to e raised to x plus y. Okay. Now, I can't take log. E raised to x का formula है मेरे पास. So what I'm going to do is, e raised to x का derivative is e raised to x. E raised to y का derivative is e raised to y dy by dx. And this will become e raised to x plus y into, can you tell me what is x का derivative? 1. And y का derivative is dy by dx. Anybody has any doubts here? No. मैंने तुमको बोला था कि for me it is very important to find dy by dx first. E raised to x plus e raised to y dy by dx is equal to e raised to x plus y plus e raised to x plus y dy by dx. I take all the dy by dx terms on left hand side and non dy by dx terms on the right hand side. So this will become e raised to y dy by dx minus e raised to x plus y dy by dx is equal to e raised to x plus y minus e raised to x. Did you guys understand this? Now, if I take dy by dx common, it will become e raised to y minus e raised to x plus y is equal to e raised to x plus y minus e raised to x. Therefore, my dy by dx will become e raised to x plus y minus e raised to x upon e raised to y minus e raised to x plus y. Did you understand this? Now see, from this, it will give rise to two sums. So the foundation for both the sums is the same. What they have asked to prove, that is important. So you have to see what are the options that are given to me. So see what I'm going to do. यहाँ पे, this is your first sum and second sum. Your first sum will become dy by dx is equal to, now e raised to x plus y का value is e raised to x plus e raised to y. So I'll write e raised to x plus e raised to y minus e raised to x upon e raised to y minus e raised to x plus e raised to y. Therefore, dy by dx will become e raised to x plus e raised to y minus e raised to x upon e raised to y minus e raised to x minus e raised to y. My e raised to x gets cancelled, my e raised to y gets cancelled. My final answer will become minus of dy by dx will become minus of e raised to y upon e raised to x. Therefore, dy by dx will become minus of e raised to y minus x. This is your first sum. Second sum. Dy by dx is equal to e raised to x into e raised to y minus e raised to x, because e raised to a plus b can also be written as e raised to a into e raised to b, and niche it will become e raised to y minus e raised to x into e raised to y. Therefore, dy by dx, if I take e raised to x common, it will become e raised to y minus 1 upon e raised to y 1 minus e raised to x, and my final answer would be dy by dx is equal to e raised to x minus y e raised to y minus 1 upon 1 minus e raised to x. Have you guys understood this? Anybody has any doubts? See, my foundation, first 5 steps are the same for both the sums. You have to just see what have they asked as your answer. If they've asked this, this is what your substitution is. If they've asked that, it should be a substitution of e raised to a plus b is e raised to a into e raised to a. Have you guys understood this? Anybody has any doubts here? No. This will be homework for tomorrow. Okay. X sin a plus y plus sin a cos a plus y, sin a cos a plus y is equal to 0. Show that dy by dx is equal to sin square a plus y upon sin a. Start solving.